Hello, respected students. We are here again to calculate the pH of HCl solutions. That's the new problem. How we can calculate the pH of 10 to raise minus 8 molar aqueous solution of hydrochloric acid. Hydrochloric acid, we know that it is the strong acid, and strong acid are completely ionized. Okay, completely ionized. It's mean when we dissolve the HCl in the water, it completely dissolve in hydrogen ions and chloride ions. Okay, so if we write down its equilibrium constant expression, that is the product concentration divided by the reactant concentration. We know that reactant is only HCl. Water is not the species, because it is a solvent. It only help in solvation as a media. So its amount is excess, and its excess amount is always in constant values. Concentrations are not written. So Ka value, ionization constant or dissociation constant of HCl is 1.3 10 to raise 6. This Ka show that acid is very strong. If acid is strong, then first we justify this reversible arrow. This reversible arrow is only used for the weak acid, not for the strong acid. In the strong acid, the arrow mostly used in forward direction because it completely dissociate. It cannot reverse to the reactants. One reason. Second reason, its conjugate base is weak base. Strong acid have a weak conjugate base. This weak conjugate base do not have a ability to accept the proton from this hydronium ion to form again HCl. Okay, next, whether we use the weak acid method to calculate the pH, if we use initial concentration of HCl, hydronium ions and chloride ions, then change, then equilibrium, it's mean this method is only valid for the weak acid, not for strong acids. So we do not use this method for calculation of pH of hydrochloric acid. We use the simultaneous equation method. First of all, write down all the balanced chemical equation relevant to the system. HCl dissolve in water. We suppose HCl as a weak acid. HCl dissolve in water and form the hydronium ion and chloride ions. We know that water also contribute to the hydronium ion. How? Because of its self-ionization. It means somewhat water is also contribute to form the hydronium ion. Okay. It means there are three types of ions: hydronium ions, chloride ions, and hydroxyl ion. In other words, there are the three types of ions, two types of negative ions and one type of hydronium ion. But hydronium ions, positive ions in other words, are equal to the all negative ions. Okay, if we write down the Kw of the water, Kw, that is the ionic product of water, is the product of concentration of hydronium ion or hydrogen ions and hydroxyl ion, that is equal to 10 to raise minus 14 at 25 Celsius. Okay, next, molarity of HCl is 10 to raise minus 8. We know that HCl is very strong acid. When strong acid dissociate, it's completely dissociate. Then number of ions are equal to the initial concentration. Number of ions is equal to the initial concentration of acids. This means chloride ion concentration is equal to the HCl concentration, and HCl concentration also is equal to the hydrogen ion concentration, that is equal to 10 to raise minus 8. Okay, we want to calculate the hydronium ion. Why? Because we wanted to calculate the pH, and for the pH, hydronium ion calculation is necessary. Okay, hydronium ion is equal to the hydroxyl ion plus chloride ion, because in the solution number of hydronium ion is equal to the number of hydroxyl ion plus chloride ions. Okay, if we put the value of hydroxyl ions from the Kw equations, how we can put this value? If we sort out the value of hydroxyl ion, we know that hydroxyl ion is equal to 10 to raise minus 14, and this value, if goes to the right side, will be written in the denominator. Okay, and value of concentration of chloride ion is 10 to raise minus 8. Okay, if we put the values from of hydroxyl ions and chloride ions from equation number 1, equation number 2, in the third equation, the new equation, new form is 10 to raise minus 14 over hydronium ion plus 10 to raise minus 8. That's nice. Next, if we rearrange this equation, if with this hydronium ion multiply this hydronium ion, that is the square of the hydronium ion, this plus 10 to raise minus 8, after going to the left side, change into the negative sign, multiply with the hydronium ion minus 10 to raise minus 14 is equal to 0. Okay, after taking this LCM hydronium ion, suppose X is equal to hydronium ion. If we suppose the concentration of hydronium ion is equal to X, then we put this X in this equation, that will be the X square. Okay, that will be the X square. Next, this hydronium ion will be equal to X multiply with the 10 to raise minus 8 plus 10 to raise minus 14. If we sort out the value of X here, we are rearranging this equation. Okay, we know that that's X square minus 10 to raise minus 10, 8x minus 10 to raise minus 14, that is equal to 0. That is the equation ready for the quadratic equation. If we apply the quadratic equations, we got the answer of X is equal to 10.5 multiplied by 10 to the minus 8 molar, or in other words 1.05 10 to the minus 7 molar. Okay, its mean hydronium ion concentration, we have find out the value of X. Value of X is equal to hydronium ion concentration, that is 1.05 10 to the minus 7 mole, and we can calculate the pH. We know that pH is negative log of hydronium ion concentration. After putting this value in place of hydronium ion, and we calculate the pH, that is equal to 6.98. Keep in mind that if autoionization of water had been ignored, calculation would have incorrectly given the pH is equal to 8. 8 means greater than 7, slightly basic. It should be, then it would be slightly basic. But HCl acid, its pH never go above 7, which is chemically impossible for acidic solution. Even very dilute one, calculated pH 6.98 is acidic less than 7 is correctly counts for the contribution of water. If we add the self-ionization water, then pH is less than 7. If we do not contribute the self-ionization of water, its mean pH will go above 7. That is wrong. It's the one method for calculation of pH of HCl. Next video we will discuss second method.